Hello everyone. Let's develop the system dynamics model. And usually a system dynamics model is used to evaluate or understand the performance of the large system like an economic system or economic market trend. So today we are going to develop the BAS model. And so in order to do that, let's create the project first in AnyLogic. And AnyLogic actually support the multiple simulation paradigm but today we are just use the system dynamics module. Let's go to file new and then click model. Okay, and then type the BAS diffusion. And let's choose a model time unit as years so that we can see the market actually trend. In other words, consumers' behavior over a year. And click finish so that you can have this new model called BAS diffusion. And in general, when you have a project, and here is a project view as well as a palette view, okay? And project view include the simulation main. So main is modeling, and the simulation main is the main view actually when you run the simulation model. And also we have run configuration and database, but we are focusing on the main actually modeling part. And so here now I see the BAS diffusion main model window here, modeling window, and this is a property view of this main window. If you want to change if you want to see the both actual window, and you can actually drag and drop like this so that you can see the main view as well as property view. And let me move a little bit. Okay, which way is better? So generally, yes, I usually put the main view here and the property view here so that when you click main, you can see each property here. So in main view, you can actually draw the models, and we are going to choose system dynamics palette here. So if you choose a palette view here, palette on the left hand side and then left side, and basically you can choose a system dynamic module here. And usually system dynamic includes stock, flow, and dynamic variables, also link, parameter, and table function, and so on. And here let's put stock first, which will give us the number of potential adapters of a certain product. Let me type potential adapter. Okay, no space. Also, let's put another stock called adapters. Then now we have potential adapters, and we want to put the flow between this potential adapter and adapters. So after some time, over the time, actually potential adapters will become adapters. Got it? So if you click the potential adapters, you can see this minus flow in equation mode, and also you can see the flow, right, in equation mode in this adapter stock as well as potential adapters. Got it? So that over the time, potential adapters will becomes adapters with a certain rate given by this flow. Okay, you can write down the rate over here later. Let's create the several parameters using this system dynamics model. First one is total population with 100,000, so 100,000 people. So in this model, we have initially we have this total population, and also you can add another one, another parameter called contact rate. And let's say contact rate is 100 per year, 100% per year. And last one, adoption fraction. And then we have one more. Let's type add effectiveness. This value is 0.011. Let's assign the total population to these potential adapters using a link. So drag and drop the link, and then connect the total population with these potential adapters. And so if you click this, you can see this warning sign, and you can type the total population as an initial value of this stock, so that you can remove this warning sign here. And now the link is changes from the solid line to the dotted line. Okay, and then let's add the dynamic variable which change the values over the time, and let's call this one is adoption from add. And so this value is over the simulation, actually does this value is will keep changing. Let's make a connection between the potential adapters and also adoption from add, and make a next connection from the add effectiveness and with this adoption from add, so that if you click adoption from add, you can actually write down the equation formula like this: add effectiveness times potential adapters. Right? So why we are doing this? We assume that this floor, so potential does become adapters over the time, but we can also assume that some of them are affected by the advertisement, okay, given by the producer or seller. So this rate will be calculated in this dynamic variable. Let's make another dynamic variable showing the influence of the word of mouth. Okay, let me change the name of this dynamic variable, adoption from word of mouth. And then it is, so basically once adapters buy this, and then definitely they can give you the opinion, give their opinions to the potential adapters, right? So that's what you call the word of mouth. And then the word of mouth also is determined by the contact rate with the adapters. Also adoption fraction plus this influence will be associated with these potential adapters, and then total population here. And let's go back to this dynamic variable and to write down the equation here. So adoption from mouth word, and you can write down the equation here. So adapters times contact rate times adoption fraction times potential adopters divided by total population will determine the adoption from the word of mouth effect. If you make all the connection, and basically you will not have any error message here. And then you can type the name, market saturation, word of mouth. Again, these will not affect your result. So these are just visualization. And save your model by clicking the save button, and then let's go to the run setup. So which is under the main. So if you click the simulation main, you can actually set up the run environment. Okay, also you can set up the parameter values. And here we want to stop the simulation time at a specified time, and simulation time will be 8 years. All right, and then if you click this bus diffusion model, you can check the model time unit. And also another thing is that if you go to main, and there is an advanced option here, and you can actually choose the recurrence time of this model, and let's type the 0.1 years so that you can see the difference. Okay, update. You can actually update the simulation model at every 0.1 years and save the model. And then you can run the simulation model here. So if you click this run button, you can see the change over the time. Okay, because also if you click this button at the bottom, and you can see the detail about the simulation time, current simulation time, and then date. Also, what else? And running time of in actual time. So, and also you can increase the speed as well. And at the end, you can see how many adapters how many potential adapters became adapters. Got it? Thank you. This is the end of today.